going to start by asking you guys for a favor. So I have to give you a little bit of background before we go. I was working on this presentation, and I was bouncing some ideas about how I wanted to do this presentation off of Dave Holzer. So if you guys don't know Dave, he's a SANS fellow, instructor, amazing guy. And you know when you're talking with one of these guys and they say something or they ask you a question and just all of a sudden it all floods into your brain. You're like, oh my gosh, I know what I'm doing. So that's what happened. Dave, thank you. Hang up the phone, get on the computer, start typing, banging out the outline, come to put an abstract together, put my title together. I am super psyched. This is it. I'm just loving this. So I take this, cut, paste it into an email, and I send it to Judy Novak. Judy is a very, very, very dear friend. She has been a mentor to me for years, the sweetest person in the whole entire planet. She is awesome. Packet Ninja, amazing. And I get an email back from Judy, and it's like, oh, Andy. I'm like, oh. She's like, this is great, but it kind of makes you sound like a boring, crabby old man. Like, Judy, I am a boring, crabby old man. No, okay, I get it. Thank you, Judy. Could you send me some suggestions? So she sends some title suggestions, changes to the abstract, and one of the titles was, haha, thanks, Judy, very funny. Kind of working through her suggestions and stuff, and my wife comes home. She's like, what you doing? I'm like, I'm working on the Blue Team Summit presentation. She's like, let me look. I'm like, sure. Now, my wife is very smart. And in the South, we call her and her family well-read. They read a lot. And she lovingly looks over my shoulder, and I'm like, this is so nice. This is amazing. And she goes, you didn't write this. I'm like, what? Of course I wrote this. She goes, this word has more than 4 letters in it. Do you even know how to say it and what it means? It says Cornucopia, and I think I know what it means. So she gets up, starts laughing, picks up her phone, and now I'm assuming she's texting Judy to tell her about this hilarious exchange. So I decide to get them back. I'm using the title in my presentation. So my ask is, if you're on Twitter today, tweet about the Blue Team Summit, all the good stuff going here, but if you happen to find Judy, and that's Novak, send her historical facts about cornucopias. I think she would love that. Hi, Judy. Good morning. My name is Andy Laman. I am a packet junkie. I absolutely love packets. It has come from, all the way back in the early 90s. I was working for Holiday Inn, and we had these stacks of equipment. They're called Landsat, and you kind of put them together, and there was this big, huge cable that ran outside to a big satellite dish, and that connected into the global reservation system, so we could see all of the global reservations for Holiday Inn. And my job was to take these stacks of equipment and put it in place. Well, they had this really, really cool little thing on the front. You plug stuff into it. It was called a serial connection. We don't have those much anymore. And you plugged in 1 or 2 commands, and you would get packets on the screen. At that point, I became addicted. It was amazing. You could really see what was happening on a network just by plugging into the serial port. That ultimately led me to some guys who were like, hey, this guy likes doing this stuff. Let's bring him to our IBM team. So he brought me over to IBM, and what I found out was they weren't bringing me over because they liked me. They didn't like working on PCs or this garbage network stuff and wanted somebody else to do it. So they armed me with my phaser. You guys know what a token ring phaser is? It looks like a little X-Acto knife, and it has the screw in it like an X-Acto knife. You open it up, and ours, you put 9-volt batteries in it, and you put the 9-volt battery in it, and when a port would quit working, you would take this phaser, and you'd walk up, and you'd plug it in the token ring switch and shock it back into working again. It was like sadist networking. It was awesome. I loved it. Well, I realized IBM probably wasn't the place for me. The suit and tie, it was kind of awkward. You know, I tried all the techniques. Guys, I can't wear a tie. I bend over and it falls in the printer and I get sucked in, and that just wasn't working. They're like, well, you're an idiot. You're supposed to tuck it in your shirt. Moved into the corporate world, working for some different organizations. We were using some equipment by this small company called Cisco. And in 1996, they released the most amazing thing I've ever seen in my whole entire life. It was NetFlow. At that point, I could find all the evil offenders on our network. I knew who exactly was sucking up all of our bandwidth, and I could prosecute them and kick them off the network. It was the most amazing thing I'd ever seen in my life. So what is NetFlow? NetFlow is unidirectional metadata about your network traffic. By unidirectional, I mean it's one direction of a conversation. So client talking to server, there is one side of the conversation that is the client to the server, and there is another flow record that is the server talking back to the client. That's the unidirectional pieces of the flow records. The metadata means there is no content. There's no deep packet inspection. There is nothing to this. It is only content. It's 5-tuple or tuple, depending on where you are from or how you learn to say it. Source IP, destination IP, source port, destination port, and protocol. That's the core of a piece of a unidirectional flow data. That's it. No metadata, or no content data, only the metadata around it. Depending on the version that you have, you may be able to get additional information like packet counts, bytes, ingress interfaces. You can get routing information, next hop, all kinds of amazing things. Now, by version, what we're talking about is the original that I first started working with in 1996 was version 1 of NetFlow. All of the NetFlow stuff was Cisco proprietary. I have no idea what happened with versions 2 through 4. They lived in the Cisco research world, and we never saw them. Version 5 came out, and you'll actually still see a lot of version 5 on networks. It's super popular today. Version 7 is almost identical to version 5, and I think it's only used in catalyst switches. You may see it somewhere else. Anyway, version 5 and 7 are a fixed format. So the 5 tuples and whatever additional information you get, that's a fixed format for that particular version. The problem is with that fixed format, you can't shove an IP6 IP address into that IPv4 space. It just isn't possible. So they came up with version 9, which is based on templates, where you can actually adjust the size of the different fields based on what the template is that's being used. All the way up to 9, it's all been Cisco proprietary. They wanted to start sharing this with everybody else, so they actually made an RFC out of version 9. But again, it's still Cisco. Community took that, they developed IPFix and have RFC 7011 plus 5, I think, maybe 6 more RFCs to describe this IPFix. Some people call it NetFlow version 10. It's not. It's open, and anybody can use it. Highly recommend that version if your equipment will support it. There are also some other versions, and they're not quite Flow. You've got SFlow, you've got NetStream, there's RFlow, JFlow. Each vendor's got their own type, but it's kind of sampled flow data. So it's not the actual part. They use some sort of statistical, whether it's deterministic or random sampling of the packets, every one of 1,000 or every one of 100, pull those packets in and keep that data. It's not 100%, but it will provide the same value over the next several slides that I'm going to show you. If that's all you got, use it. It is still very popular stuff. So what can you do with flow data? Well, I'd like to encourage you to think about maybe becoming more data-driven. Challenge you to maybe move a little bit away from your alert-driven systems and start looking at the data that you have and understanding what's on your network and how can I utilize that information to figure out what's going on in my environment. So what do I mean by alert-driven versus data-driven? So as defenders, a lot of our products have been built and developed to be alert-driven. Our antivirus, IDS alerts, we get alerts to say, hey, this may be bad, go look at it and do something. That's the starting point. That's not the end. That's the starting point of us going to research or do something. Data-driven analysis is where we take the information and we start looking for bad. Look in our environment. Is this normal? Does this look normal for our protocols? Can we profile our client behavior? Can we profile our server behavior? Is this what is happening on our network, and should it be happening on our network? For example, this is some of the top ways that people are using flow data. You're looking at, for example, the most bytes. Who consumed the most bytes on our network? That's usually to show something like data exfiltration, right? The top consumer, they're sending data outbound. It's, exfiltrating data from our network. That works. Longest connections. How long are network connections generally? They're pretty short, right? Really short, pull down this image, pull down this content, do something with it. Do you guys know actually how long the average YouTube video watch is? Does anybody know that? Yeah, the last thing I saw was 4 minutes and 20 seconds. So all you future video blogging people, make your video shorter than 4 minutes. That's the longest of those YouTube video watches. Okay, so yeah, somebody could be streaming a video, a movie, and that movie may come down in the one single stream. So what are we talking? 2.5, maybe 3 hours? Should you have connections that are lasting 4, 8, 10 hours on your network? Is that something you could look for? Command and control channels, maybe a slow, long data exfiltration, something that you could look for. What about the number of connections? A host that talks a lot. Hey, here's a connection, here's a connection, here's a connection, here's a connection. That's usually some sort of beaconing. That could be some sort of anomalous activity on your network that's worth investigating. But let's twist that just a little bit. So this is a month's worth of data. You're not going to be able to read the stuff along the bottom. It's April through June, and every kind of column is one of the days of the month. And this is a web server that was sitting in our DMZ. This is very typical web server traffic. There's nothing abnormal about this. Small client request, lot of data back to the client. So little bit of client in, lot of content back out. Very typical. What drew this to our attention was the fact that this server in our DMZ was not on any of our asset lists. Now, okay, look, I get it. I don't have 100% accurate asset lists, and our network diagram may not be 100% accurate all the time either. That is not traditionally overly surprising. That is okay because it's a human thing. It all happens. What became more interesting was this server never had any vulnerabilities, ever. And it never showed up on a vulnerability scan. Now we're starting to get a little bit suspicious. Okay, we could have missed it out of our inventory, but how is a web server never had a vulnerability and never showed up on a scan? Well, this was actually one of our own sysadmins running a, let's call it a not safe for work personal enterprise out of our DMZ. And his web server happened to be hosting content for his not safe for work enterprise that he was using our bandwidth for. And he knew that on the 15th of every month, our vulnerability scanner ran. So he very wisely turned down his server on the 14th, left it off on the 15th, and then once the vulnerability scan results came back out, he turned his server back up on the 16th and continued his enterprise. As Randy pointed out yesterday, know what's talking on your network. We did a really, really poor job of that, obviously for at least a quarter that this guy was running this server without us knowing. Using flow data, using only the metadata, being data-driven, looking for what's normal on our network, and seeing how can we figure out if these things are good or bad, suspicious, malicious, or benign. DNS. Everybody agree that this is generally a reasonable depiction of how DNS works, right? Client says, hey, I want to go to evilandy.net. Local DNS server goes, is it in my cache? Nope, not in my cache. Ask the root server. Root server says, hey, go ask the name server for evilandy.net. Name server for evilandy.net says, hey, here's the IP address. The IP address goes to the local server. Local server gives it to the client. And are we amazed that the internet actually works? This is a pretty simple depiction. This is exactly how this works. This is normal. There is a ton of amazing content on how we can use DNS and use payload data in DNS to look for evil on our network. I mean, there's like full course sections in SANS courses, 511, 503, 555. There's tons of material on how to use this information to find suspicious or malicious things on your network. It's amazing. But what if we don't have the content? What if we only have the metadata? Could we figure out if something is suspicious or malicious with only the metadata, understanding how DNS works? So this is Silk. This is Silk output. This is our 5-tuple or tuple of information. Source IP, destination IP, source port, destination port, protocol, which you'll see is 17. This is UDP traffic in this slide. And I've included the packets, bytes, and the duration in this output. This is very normal looking DNS traffic. Client asks the server, server responds with the packet. Client asks the server, server responds with a packet. Unless you think a little bit about how DNS works. I'll talk about eDNS in a second. So any of you extended mechanism DNS people, don't freak out. I get it. We'll be there in just a second. The maximum size of a UDP packet for DNS is 512 bytes. Do I see some very odd UDP packet sizes for DNS traffic? Absolutely. This is actually DNS Cat 2 from a red team exercise where they had a command and control channel set up, and we were able to pick it up just based on the metadata of the size of the DNS packet. So does eDNS, which has opcodes to allow you to have larger UDP packets, impact this? Absolutely it will. Has it impacted me yet? No. All of this has still been valid and has still been a valid detection mechanism for us only using the metadata to find suspicious things with DNS traffic. Okay, this is going to be the interactive part. I'm going to stand up here and be awkwardly silent if you guys don't respond to me. In a normal Windows Active Directory environment, where should your clients get time information from? Thank you, the domain controller. Could you potentially, using only the metadata around NTP protocol, figure out hosts that are on your network? Flow data, being data-driven, looking for the information that's on your network. This again is Silk. I put the command up here to show you this isn't some black magic voodoo statistical analysis that I'm doing. This says RW filter, which is a Silk command, and I'm pulling out of a repository, so I need the type, which basically just says give me all the different types of traffic. A port says any port. I'm saying 123, which is the NTP port. Send that to the standard output, pipe that to RW unique, which is another Silk command that says, give me the unique instances for the destination IP field. That's all I've done. Super fast, super easy, really quick look at what's going on. So if all of my Windows domain clients, which this is a Windows Active Directory environment, should be getting their time from their domain controller, why do I have other things getting time? Well, the red is Apple products. Thank you, Apple, for participating as a good network citizen, but wanting to use your own NTP server. Don't know what to tell you. Apple products on the network, they're going to try and talk to Apple to get their time. The yellow, Red Hat. This actually was a mistake by a sysadmin. They were not following their build guide that said, hey, point this to your internal NTP server as part of your build guide. They missed it, complete mistake. Hey, you know what? No big deal. We're humans. Find it, fix it, move on. Green, Microsoft. Wait a minute. All the clients should be getting it from the domain controller. Why do we have clients reaching out to Microsoft directly? Well, we do have developers. And in this particular case, this developer decided they wanted to spin up their own server. Thankfully, our developers do not have the ability to join things to the test domain. Since it wasn't part of the domain, it was trying to get time information from Microsoft. Cool. Hey, should they have done that? Probably not. Is it a big deal? No. Fix it, move on. Bloo? Any guesses? That's our security admin spinning up an Ubuntu VM to do some analysis. Nice, yeah. So good. So we have these three white ones. What is this? This is pretty, we shouldn't have any clients going anywhere that we don't know about. Well, this one was kind of weird. It was one of those printers. I don't even know if you could call it a printer. It's this big multi-function thing. It was huge. I mean, it was like the size of a dresser, and it would fax and email and scan and print, and I think it sent postcards when you were on vacation. I don't know. This thing was crazy. It was huge. Our team had actually set it up correctly. What we didn't know was the vendor software didn't trust the IT team, so they had this JavaScripty app thing built into their app that actually would check and validate the time. Okay, because that makes sense. No big deal. We figured it out, reconfigured it, got it working. Everything was in good shape. What was this? So we had an employee, and they had to have their music. So they brought their music device in. Now, this just wasn't a music device. This was also one of those devices that you could ask it things, and it would, give you information out of the internet. Or you could say, hey, ship something to my house so it's there when I get home. You can ask it things, and it would respond and do stuff, but it played music. So our very wise employee got their music device. They brought it into work, and they were going to connect it to the guest wireless network so nobody knows that they had their music device at work. The problem was, if you ever noticed that there's no interface on these devices, you couldn't figure out how to get the guest Wi-Fi because there's no interface on it. He had to have his music, so what does he do? Plugs it into the corporate network. Okay, well, please don't bring your devices to work. Take it home. We're good. Thanks. This one was a little weirder. We started looking at it, and it wasn't, really quite that NTP server. Just that little bit off, that little bit, you get that gut feeling. Something's weird about this NTP server. So we kind of looked at it. That's not generally what I get when I query an NTP server. I have no idea what this was. I don't know why this NTP server was sending this traffic. It was somebody's personal device. Our HR and legal team advised us to tell the person to take their device and go home and never bring it back again, but they should probably have someone of professional expertise look at it or maybe wipe and re-image it. I don't have any idea why this server was, or this client laptop was going to this site. I don't know anything outside of it, but only using the data that we had, only looking at the metadata, were we able to figure out kind of what was going on our network? Could we find some devices that shouldn't be on the network and get rid of them? Ping. Because if you can't ping it, it doesn't work, right? ICMP echo request, ICMP echo response. Everybody knows how this works, right? Ping, ping response. ICMP echo request type 8 code 0, right? ICMP echo request, type 8 code 0. To the receiver. The receiver receives that packet, takes and turns the type 8 into a 0. So now it's a type 0 code 0, keeps everything else intact, and sends that back to the client. Ping, ping response. Echo request, echo response. If all I'm changing is that one byte, 8 to a 0, everything else is intact, the size of the packet should be the same, right? Everybody agree with that? That's a pretty reasonable thing to look. Ping, ping request. Ping, ping. Is that a normal behavior? Yeah. There's things that may not be up. There's things that may be down. That's the whole reason for the protocol. Should it ever be ping, response, 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 response? Probably not. Should you ever send a single ICMP echo request out and receive multiple responses back? No. Have we looked at any data yet? No. Is this suspicious? Yes, absolutely suspicious. This is a crazy suspicious amount of information that you can find just by looking at what's going on your network. This is actually an SSH tunnel over ICMP using ptunnel. So this was they had a SSH tunnel outbound, and they were hitting their server and basically using SSH over ICMP. You can figure that out because you should not be receiving more packets back than you actually sent using the ICMP echo request and echo response. We look at using our data, becoming data-driven, figuring out what's normal on our network, maybe looking at things with a little bit of a twisted mindset, maybe looking at it, that tad bit differently. How does this lay out? What does this look like? Thinking about what is normal, and can I find anomalies for things that are not normal? But I haven't told you what I really like about NetFlow data yet. This to me is why it is super powerful. But to do that, we have to build a network. Our network is going to have some clients. Yes, I know network engineering and security people think the best networks have no users. That's probably not very good for the business, but I get it. No users, very secure, very fast-performing network. We're good. Ours is going to have some users on it. We're also going to have some servers, right? We've got our little web servers, and they've got some database servers behind them because our users need to access stuff. And we're going to have an internet presence, so we're going to put some DMZ servers. Our DMZ servers are going to be, set up correctly, only have web services on them, sit out in a DMZ. But if we have a DMZ, we have to have a firewall. Right, Randy? We have to have a firewall. And the best firewalls are built out of bricks with flames on them. That's the best firewalls. So we're buying the best firewall. Well, now we have to connect everything. Now we know this is all connected because that symbol is a router, and we know it's a router because it's got the little arrows on it. It's not a database because, the databases don't have all the little arrows on it. Just so everybody's clear, that's a router. Well, now that we're connected and we're on the internet, it's now a scary place. We now have evil people who want to attack us on the internet. Well, we're not just any ordinary company. We have monitoring tools. And not only do we have monitoring tools, we have the monitoring tools. These tools are so amazing. Not only does it do signature-based detection, it does anomaly detection. It's got heuristics that use AI and machine learning with blockchain. And I think it actually even gets you Bitcoin. Have I used all the terms? I think I've used them all. Bitcoin in off hours. This is amazing networking equipment. Absolutely the best monitoring tools that money can buy. We're going to connect it into our DMZ. We're going to connect it between our wire and firewall. No one is going to be able to get past us. This is the best. Except for our evil person sends a, I don't know, what do we want this to be? A phishing email, because phishing never works, right? Send a phishing email in, and we got to click the link. We have got to see the puppies, right? There are puppies on the internet that we haven't seen yet. We have to click the link. They click the link, and it sends an outbound command and control channel. Now, normally our tools, our awesome stack of AI machine learning awesomeness is going to pick this up. But you know what? This case, our attacker, she is super smart. I mean, she is amazing. And she knows that we have this awesome machine learning AI signature anomaly magic going on. And she did something crazy. She used HTTP2 over TLS 1.3 with IPv6. That's it. We're blind. None of our tools work with any of those, so she now has a command and control channel in our network, and we have no way to detect that. Being smart, she knows that she doesn't want to just stay on that one box. She needs to laterally move. She needs to move somewhere to be able to keep her presence and start trying to find the data, which is what her ultimate goal is. So from this infected machine, she starts scanning. She scans the local segment, scans another segment, scanning through the network, starts scanning some servers. Have we passed anywhere yet that our monitoring tools have seen this? Have we given our monitoring tools a chance to even detect this yet? No. Jonathan talked yesterday, architecting the network to be able to see this stuff. Is NetFlow potentially able to provide us this visibility? Well, yeah, absolutely. Why would I be going through this whole scenario if I wasn't going to bring that up? NetFlow is a perfect way to check for lateral movement, to check for scanning, to check for client-to-client communication, because it can be embedded deep within your network. You can pull that data from really, really, really deep into your network and get visibility that you couldn't normally either do or afford with your other monitoring tools. You're not going to be able to read the Silk output on the left side of the screen. I get it. It's very loud. That's the purpose of this. All this is I ask Silk for source destination IPs on the same client or on the same segment with TCP 445 traffic. That's all this is. That lit up just amazing. I mean, tons of traffic. Pulled out a couple of excerpts. So the top is a normal client that is active and responding. So 100.103 sends a SYN packet to 100.101, and 100.101, I'm assuming, because this is only metadata, sends a reset ACK back. Hey, I'm not listening on that port. You can't connect to me. That's a very normal behavior. Now, should my client be trying to connect to another client on the same segment? No, not in this environment. There is no reason that should be happening. The bottom section is showing when either the client is not on the network or maybe there's something keeping it from talking, like a firewall or some sort of host-based device on it. So, SYN, hey, are you there? SYN. Nobody's responding back. But we can still see that with the flow data. Remember, it's unidirectional. There's no conversation or anything that has to happen. We see this client trying to communicate to all of these hosts on the network. The middle, that's very suspicious for me. So we have 103 talking to 148, SYN, ACK, and there's at least 12 packets from this snapshot where we pulled it, and data that was transmitted between these two devices. So one, if my client should never be talking to other clients in my environment, this is bad. Two, the fact that they're actually communicating and transferring data, this is super potentially bad. This is suspicious and something that I should look at. All of this is still metadata. We have not looked at any content yet, but we have been able to find attempted lateral movement, potential lateral movement from a compromised host. On your network, should clients be talking to other clients? Even if you were doing things like private VLANs or, microsegmentation or whatever buzzword that you wanted to see, you can still see this data with NetFlow because that client is still going to send that SYN packet. That client is still going to try and attempt that client-to-client communication, and you'll be able to extract that from your flow data and see those attempts because you're so deep within your environment. Now remember, I'm an old school NetFlow guy. I love this output. I like the text, this is how I look at it. This is easy for me to see. This is easy for me to digest and understand. This may not be the best way for you to look at it. Flow data, again, is only the metadata, which makes the data points very, very easy to manipulate and very easy to visualize. This was super easy. All I did was take the source IPs and the destination IPs out of that Silk output, and I shoved it through GraphViz, which is open source on Linux, and said, hey, give me a visualization of who's talking to who. And you get the graph on the left. So this is pre-infection. The little blue dots, can you see that they're blue? Yeah, the little blue dots are one client, one segment. The little green dots are another segment. The big orange thing in the middle is the file server. So yeah, client should be talking to the file server. The kind of one-off things are shares that are departmental shares on those segments. So that's kind of some one-off traffic that you're looking at it. And that little bitty dot there, that's the soon-to-be clicked on the puppy links infected person. Is there visually a difference in the right side of the screen on how that client is operating after it gets infected? Is that pretty easy to see, hey, something has gone awry here. Visually, I can see that I need to probably look at that device and figure out what's going on with it. The data points within just the metadata of flow data are super easy to grab, super easy to manipulate and visualize if that's something that you want to do, if that's an easier way for you to digest this. So how do you get this information? So I said it's deep embedded into your environments, and it is. On, we'll say most commercial routing and switching products, I would almost say all, especially if they're enterprise class level, NetFlow is built in, or some sort of flow data, SFlow, JFlow, some sort of data to be able to extract and pull flow is built into these products. And almost every vendor gives you that with the base operating licensing fee. So it's free. You already have it. It is incredibly surprising to me to go into customer locations and they don't have NetFlow. It's there. It's free. It's enabled to be turned on. Now, in some cases, the networking team is using it. If your networking team is using flow data, ask them for access. Pay for them to do something so you can get access to it. It's valuable information. Where some people get hung up is where do you send that NetFlow data? So I can get it configured on my exporters, my routers and my switches to send it somewhere. That's to the collector. There are a lot of amazing commercial collector products. I mean, amazing products. But they range from less expensive to way too expensive for any budget that I've ever had. Some of them are very, very expensive. So that can be an issue if you jump right in and start looking at these very expensive collectors. You can say, hey, this is out of my price range. But it doesn't have to be. You can get very, very popular great collectors in things like Silk. Every slide that was built for this was all built on open source information. So you can get Silk information, you can do Etherflow, you can do Argus. There's a bunch of good commercial or free open source products that store the data. Remember, it's metadata in a very, very small footprint that's very, very fast to be able to digest and process and look at and get access to what's going on in your network. If you're a SIEM person, you can actually bring your flow data into your SIEM. Now, I'm personally not a huge fan of this. If you go down this path, maybe try to go the tactical SIEM route, like what Eric was talking about. For me, I need this data fast, especially if I'm looking at weeks, months, potentially years worth of flow data to try and visualize and put together a picture of what's going on in my network. SIEM ingestion of flow data may not be the best performing depending on what you're trying to do. It's an option. If that's what you've got, go for it, right? Enrich the data, bring it into your environment, start looking at it. It gives you context around who's talking to whom. It's a very, very good way to try and pull and get that information and to get it into your environment if that's all you got. Again, I like the text-based model. I personally like Silk a lot. Free, open source. It's a little bit cumbersome to get set up, I understand, but there's options out there. It's available. You can get visibility really, really deep into your network. But now you're like, yeah, Andy, that's all right. But listen, we're in the cloud. We don't do this stuff anymore. We've moved to the cloud. Well, guess what? You can get it out of the cloud too. Every cloud provider that I've worked with allows you to pull some sort of flow data out of your environment. Now, it may not be directly in a flow format. Some of them come out in JSON format. Some of them come out in text delimited that you have to import or put somewhere else. But you can get this data out of the cloud. Who is talking to your cloud instances? Can you see that today? Have you looked to see who or what is talking to your cloud environment? You can do that with flow data. You can go pull this information out of the cloud and figure out who's communicating to your instances. Are people outside of your organization trying to connect to and access your instances in the cloud? You can look and see that. It gives you visibility into all areas of your environment that you had no idea you could see. Becoming data-driven, moving a little bit away from the alerts, looking at what you have, and trying to figure out what's going on in your environment to find suspicious, malicious information about your client's host servers. So network flow data, again, metadata, really small, super, super fast. It can get you visibility into all kinds of areas, even into the cloud platforms. You can actually take that data and you can plot it, you can manipulate it, you can make changes to it, you can use it to profile system behavior, you can, figure out what's going on in your environment, and it's probably already running in your environment today. You have the licensing. You have the ability to go get this data and look at it. Well, thank you guys very much. I really appreciate it.